Should be another short video here for you today with lots of vocab and a few practice problems, but not too many because I think they're self-explanatory. We'll start with what is a polygon. In geometry, a polygon is a plane figure, meaning it exists inside a plane. It's closed, has the following properties. Must be formed with 3 or more line segments, and those are called sides. This is pretty important, number 2, that people forget about. Each side can only intersect exactly 2 sides, and they have to be at the endpoints. So no 2 sides with a common endpoint are collinear. Meaning BC is a side and CD is a side. Notice that B, C, and D are not collinear. The sides aren't collinear. Each one of those points is called a vertex. Together they're called vertices. And then we can name a polygon by picking one vertex and going around counterclockwise or clockwise in order. So A, B, C, D, E. You could also do C, D, E, A, B. You could also go backwards and do E, D, C, B, A, as long as you go in order. Another important property about polygons is their names and how we classify them. I'm sure you've heard of the first few quite a bit. 3 sides is a triangle, 4 sides a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon. Some people confuse it with septagon, not sept, hept, it's Greek. But then we do get into some Latin, octagon and nonagon and decagon, and then 12 dodecagon. Anything else we'll just call n-gon. So a 43-sided polygon is called a 43-gon. Just an interesting aside, I've said it before, October was originally the 8th month of the year, November was the 9th, December was the 10th, and that was it. Then Julius Caesar came along and said, I want a name for myself, and I want to name a month for my nephew, Augustus, and we got these 2 months. We're actually on the Julian calendar. He stuck these 2 months right in the middle of the year because that's when the weather was nice, and he wanted his month to be the nice weather as well as his nephew's month. So after June, it used to be September, which was the 7th month, and October the 8th. Now October is the 10th month because of this guy. Another really important idea with polygons is how do we talk about polygons, about convex and concave? And it's more easy to see with this diagram from the textbook. It's a really great diagram. We say a polygon is convex if no line containing a side contains a point on the interior of the polygon. So if you extend this side, it wouldn't hit in any point in the interior. Look at this point here, concave. This side here hits points on the interior. This line here hits points on the interior. No other line does, but if any one line does, it is a concave. You can think of con in Latin, that meant width, and cave, you could actually kind of think of this as like a little cave or nook. The other thing that's important that I glossed over is that the definition of polygon uses line segments. So any curved segment, any kind of curved line doesn't count because line segments can't be curved. Other important definitions, equilateral, equiangular. I think they're pretty obvious. Lateral meaning side, equilateral, equal side. Equiangular, equal angles. If we have a convex polygon that's both equilateral and equiangular, we say it is a regular polygon. Notice a regular pentagon here, but a pentagon is anything with 5 sides. So this is a pentagon. It's not regular, but it's a pentagon. This is a quadrilateral. A regular quadrilateral you're so used to, and that's a terrible drawing, but a regular quadrilateral has a special name called a square. All the problems that you'll do in section 1.6 deal with knowing those definitions. So they'll say, here's a regular pentagon. Find the sides if one side of the pentagon is 5x minus 3, and the other side of the pentagon is 2x plus 8. And what you need to know is regular means that they're equal, so 5x minus 3 equals 2x plus 8. I'm going to add 3, subtract this, or sorry, add 3 to both sides, subtract 2x. I get 3x equals 11, divide by 3, x equals 11 thirds. Remember though, it might ask, what is each side? So you plug in 11 thirds here, you get 22 thirds plus 8. That's 22 thirds plus 24 thirds. And the best answer for a length of the side in this problem would be 46 thirds. Please start working with improper fractions whenever possible. Stay away from mixed numbers and definitely stay away from decimals. Believe me, long run, fractions are your friend. The next lesson, 1.7, is also a bit of review, so that's why I've combined these two, hoping it'll go fast. It's a review of what is perimeter and what is area. So we should review those terms, but I'm hoping it's something you're familiar with. So perimeter is the distance around a shape. So for a square, the perimeter are the four sides added up, or 4s. For a rectangle, it's the length plus the width plus the length plus the width, so we have this nifty formula, 2L plus 2W. But it's really, perimeter means adding up all the sides. For a triangle, add up A, B, and C, and then all of a sudden you've got the perimeter. For any polygon, the perimeter is adding up the sides and giving a distance for the perimeter. For a circle, we have a special name for perimeter. It's not called perimeter, it's called circumference, and that's the distance around the circle. The best formula is 2 pi r, but knowing that 2 times r is the diameter pi also works. I will always use 2 pi r. I just do. Area is an important distinction from perimeter because area is square units. It's a side times a side. It's a base times a height. It's a length times a width. If it's a triangle, if it's half the base times the height. And what's interesting about half the base times the height is if I could draw the exact same triangle here but upside down, where this is A and this is B, you can see it has the same height, and you can start to see this quadrilateral shape that would have a base B and a height H, and the entire area would be base height, so half the area is that triangle. For a circle, we use the formula pi r squared. Again, something I hope you're familiar with. You take the radius and you square it, multiply by pi. Just like we've been practicing, the square root of 128, the best answer is an exact answer, 8 root 2. The best answer for circumference and area will be in terms of pi. We won't have to multiply it out all the time. If I told you the radius here was 4, I would like to see that the circumference is 8 pi units and that the area is 16 pi units squared. That I feel is a better answer than whatever 16 times pi is. If you have to round, please use the pi button on your calculator because it's more accurate to a few more decimal places than 3.14. Remember, pi, like the square root of 2, goes on forever. So we like the number 8 root 2 and we like the number 8 pi, or we like the number 16 pi. Don't forget, area and perimeter should have units. You'll want to be very careful when dealing with units, especially squared units. So we've seen this in physics, that if you take 48 inches, you can multiply that by 1 foot in 12 inches, and then the inches cancel. 12 goes into 48 4 times, and you get 4 feet. But if you were dealing with 48 square inches and you multiply by 1 foot in 12 inches, you're not going to get feet, you're going to get an inch foot because only one of them goes away. So instead of multiplying by 1 foot in 12 inches, you need to multiply by 1 foot squared in 12 squared inches squared. Notice that if you multiply these together first, you would get 1 foot squared over 144 inches squared. Now if you multiply this by 48, the inches squared cancel, and you're left with something in terms of feet squared. 48, this has a factor of 12 in it, has a factor 4 times, and then this has a 12 here, and then 4 goes into this 3 times, and you end up getting 1/3 foot squared. So 48 square inches is only 1/3 of a foot squared. So to kind of visualize that, here is 1 foot. Here is 1 foot. This is 1 square foot. I could break this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that might be more. But you could see the 144 square inches that would be there. I'm not going to draw them all out, but you can kind of visualize this, right? This little guy here is a square inch. This big one here is a square foot. So when you're working with units, and you're going to change square units into another square units, the best way to do this is to think about all those conversion factors that we've been talking about. 1 foot in 12 inches, or 3 feet in 1 yard. And if you need square units, square this whole thing and square this whole thing. And then if you're good at algebra, you know when you square this whole thing, everything gets squared. 1 squared is 1. Feet squared is feet. Feet squared. 12 squared is 144. Inches squared is inches squared. 3 squared is 9. Feet squared is feet squared. 1 squared is squared. Yard squared is yard squared. These are the conversion factors you use when you're dealing with square units. I think that's all you need for the video. I have assigned a lot of problems for an hour-long class. Your job is to do as much as you can. You should be able to finish 1/6. Your homework will not be a video. It will be to work on 1/7 for 30 minutes, then come into class and study 1/7. It's about time for a math test, so be expecting a math test on Monday of next week. All right, peace.